Hello and welcome to another Algebra I video tutorial. In lesson 11.7 we'll be looking at permutations. Our goal will be to find the number of permutations of objects without replacement and introduce factorial notation. Okay, so let's say you are a baseball coach of a little league team and you have 9 players that are pretty evenly skilled, and you want to pick the batting order for tomorrow's game. How many different ways could you sit up and write out the order of the batting rotation? So hopefully by the end of this lesson you'll be able to answer that question and realize that's quite a few different ways. Suppose there were only 3 letters A, B, and C. Notice the difference between the 2 types of arrangement. So let's say we pick 2 letters at a time, or maybe more. So let's say we had length 2 with replacement. There would be this many ways you could use the letters A, B, and C. You could have AA, AB, AC, BA, BB, BC, CA, CB, and CC. So that's quite a few different ways. So we've looked at that kind of counting problem before, right? Length 2 with replacement. Well, you had 3 letters and a length of 2 with replacement, so there could have been 3 choices for each, and 3 times 3 is 9. And if you count how many there were 9 of those. Okay. What about a length 2 without replacement? This is a permutation. So we go AB, AC, BA, BC, CA, CB. So that means you had 3 choices for the first letter, but without replacement, meaning one letter's been taken away, so it'd only be 3 times 2, because 3 choices for the first letter, and then only 2 choices for the second letter, which only gives you 6. So that's the difference between with replacement and without replacement. You can't use the same over. All right, what about length 3 with replacement, meaning you could have all 3 the same. There's quite a few, because it'd be 3 times 3 times 3, 3 choices for each letter, and that's 27 different arrangements. What about length 3 without replacement? That would be 3 choices for the first letter, 2 choices for the second letter, and only 1 choice for the third letter, which gives you only 6 ways. So with replacement, there was 27 different arrangements of the 3 letters. Without replacement, there was only 6 ways you could have those together. So let's say a length 4 with replacement. That would be 3 to the 4th power, so 81 different arrangements. If we listed them out, it would take a while. What about length 4 without replacement? There's none. There's not possible, because you only have 3 letters, A, B, and C, and you need a length of 4. So to get that 4th one, it would have to repeat. We can't repeat it because there's not replacement, so that's not possible. All right. First example here. Let's say after a student asks a classmate for his phone number, they notice that the last 4 digits of the number contain only the numbers from 1 to 4, and they wondered if this was unusual. So how many 4-digit numbers are there with digits from 1 to 4, meaning they could be the same, so there's with replacement. So that means there are 4 digits, so and they're only one from 1 to 4, so 1, 2, 3, 4. So 4 for the first, 4 for the second, 4 for the third, and 4 for the fourth, which ends up being 4 to the 4th, which is 256. Okay, and then part B. The student looks more closely and notices that the numbers are all different. So this would be like without replacement, because they're all different. So how many possible 4-digit numbers fit that criteria? So 4 choices for the first, 3 for the second, 2 because they're all different, times 1. And that ends up being only 24 different ways. Now, this thing called factorial notation, if you have this pattern, 4 objects, and you want to multiply all the integers down to 1, that is 4 with an exclamation point, meaning 4 factorial, which means 4 times 3 times 2 times 1. So if you had like 80 factorial, you wouldn't want to write 80 times 79 times 78 all the way down to 1. You would just put 80 with an exclamation point, and that's factorial notation. All right, number 2, a concert will feature 5 different bands. In how many different orders can the concert producer organize the bands? Usually you'd want your best one playing last, because you'd want people to stick around for the whole concert, but let's say they're all fairly close in popularity, so 5 different bands. Well, that means you could have any of the 5 play first, but they're not going to repeat, so we're going to go without replacement. So then there's only 4 could play second, 3 could play third, 2 could play second to last, and then only 1 to go last. So that would be factorial notation, 5 factorial rather than writing it out like that. And 5 factorial is 120. 120. So there's 120 different ways you could choose to organize the bands, the order that they will play. All right, number 3. There are 10 people in a race. Assuming none of them tie, in how many ways can they arrive at the finish line? Okay, well, if we're going to order all 10, there would be 10 ways they could finish first, and that person can't have anything besides, there's no replacement. They can't get first place and last place. So 10 could get first, then 9 could get second, 8 could get third, and so forth and so forth. So that's going to be 10 factorial, and 10 factorial is quite a few different ways. That's 3,628,800 different ways. Okay, so for you to predict the order of people in that race, first, second, third, all the way to 10th place, you would have 3,628,800 different ways you could do that. But most common, we just probably, if we're maybe betting on the race, like a horse race, we'd probably pick first, second, and third place. So how many different ways could you pick first, second, and third? Or how many ways could they finish first, second, third? Well, there's still 10 ways they could finish first. 9 ways for that second place person. 9 people left to take second. And then 8 people left to take third. And that's all we care about. We don't care about down to 1 because we're only looking at first, second, and third place. So 10 times 9 times 8. 9 times 8 is 72 times 10, so there's 720 different ways. So we can't use factorial notation for this because we're not going down to 1. We're just going 10 times 9 times 8. All right, number 4. Let's say 500 people enter a raffle. The first prize is a 4-wheeler and the second prize is a mountain bike. So how many different ordered pairs of people are eligible to win these prizes? So if we're picking the 2 people, there would be 500 people could win first prize times 499, right? Because that person can't get first and second. So 500 times 499, that would be 249,500 different ordered pairs of people are eligible to win those 2 prizes. All right, so part B, suppose you and your best friend buy raffle tickets. What's the probability that you and your friend were the 2 to win the first and second prizes? Well, there would be only one ordered pair of you and your friend would only be one ordered pair out of this possible 249,500. So not real likely that you and your friend are the winners. All right, calculate 75 factorial divided by 74 factorial. That is, your calculator may or may not do this because these are huge numbers, but you wouldn't need them to do this. This should be a pretty quick answer. 75 factorial would be the same as 75 times 74 all the way down to 1, but it's also the same as 75 times 74 factorial, right? 75 factorial is the same as 75 times 74 factorial divided by 74 factorial. So 74 down to 1, all those factors, and 74 down to 1, all those factors, will cancel out 2 ones. So 75 over 1, which is 75. Pretty simple answer. You would not need to reach for your calculator for that one. All right, what about 100 factorial divided by 98 factorial? I know most of your TI 83s and 84s would not even do this type of problem because it will give you like an overflow because there's too big of numbers. You wouldn't need it to do this if you understand factorial notation. So this is 100 times 99 times 98 all the way down to 1, or I could say 100 times 99 times 98 factorial, because down here I have 98 factorial, and all the factors from 98 down to 1, all the integers from 98 down to 1, will cancel out to 1s divided by itself. So it's 100 times 99 over 1, so that is 9,900. So we can do a calculation such as this that our calculator cannot process. All right, so that wraps this up. Your assignment will be 11-7, page 694, 2 through 24 evens, and hopefully you can come to class with an answer for that baseball question, how many different ways could that Little League coach pick his batting order? And there's 9 batters. He needs to order them. All right, thanks for watching, and we'll see you next time.